So, good evening, guys. So, today we will talk about a topic wherein we require extra data. Okay. So, when right now, if you when I'm saying extra data, it means that when you're running a MapReduce job on a particular data set and you need an extra information externally, you need an extra information to solve that MapReduce job. Now, to solve that particular problem, you need an extra data. Sometimes what you do actually in real world is that you have a let's say if you talk about in a data warehousing concepts, so you have a lot of tables and you wanted some information from that table. So what do? You do joins. You do sometimes equi join, sometimes you do a internal left outer join, right outer join, sometimes you do right. So all those joins you do and get the data. So joining is nothing but on one table you are trying to fetch the information from another table and doing some calculation or some business problem trying to solve. Similarly, there will be a lot of scenarios when you are working with MapReduce also, that when processing some data set, when you're processing, you need information from other data sets also. So what I'm trying to say, you will not have all the information in one data set. Okay. So you will have some information in one data set, you will have some information other data set. You need to process both of them and do some and bring and do some, I mean say, do solve some problem, some business problem. Okay, so what we are trying to do is today is the similar kind of problem statement. Let me first give you the problem statement what we are trying to solve. So we today at a high level, let me tell you that we are going to actually solve a MapSide join problem. It's a kind of a join problem, but I don't want you to bring this terminology join. All right, I wanted to use a more layman language, like I am processing I'm processing a data set, and while solving a business problem, what is the problem? I'm going to define it right now. While solving a business problem on this data set, I need some information from the other data set which is present, right? For example, the problem statement is I have an employee data set. I have an employee data set, and the problem statement is from this employee data set, we need to replace the location ID of every employee record with the corresponding location name. Okay, it's a very simple problem statement, but I would like to bring up the fact of using an external data set. So what I'm trying to say, we have an employee data set. Okay, and this is employee data set which I am actually showing you right now. This is an employee data set which is a CSV. Okay, I have opened a CSV sheet CSV, right? Employee table.csv, and in this data set, what I want to do, replace the location ID of every employee record with the corresponding location name. Okay, so this is your first name. Let's say the first column A, the second column B is your last name. The column C, this column is some industry, and the D column is address, whatever. But this G column, if you see, the G column is actually a location ID. And as I've just told you, what we have to do is to replace this location ID of this corresponding location ID, corresponding location name, and then it's a number, and then some state code or zip code, address, email ID, and whatever. So this particular data set, in this data set, I wanted to replace this location ID with its corresponding location name. So Alaska, Arizona, New York, New Jersey, Illinois, whatever, right? but where is that data set which has the mapping of my location into the location name? So if you see, I have given another data set which is us underscore state.csv, which has two columns. The first column is basically your location ID, and the second column is your location name. Now, so you have both the information, but what you need to do, you need to use these two data sets and do and replace it. In traditional RDBMS world, you might have these two information into two tables, and you would like to do an inner join on these two tables, and that would be very simple. But now we are doing a map reduce job to solve this problem. So we have this. I have an employee data set, and what I need to do, replace the location ID of every employee record with the corresponding location name. Okay, so couple of things what you need to do, what you need to understand, what are the various challenges, problems. I mean, to problems in the sense, to solve these problems, what are the various things you have to ask yourself? What are the various questions that has to be first answered before you start solving the problem? Okay. So first, let me say step one. What I need to do, what we will decide. Okay. Since employee data set is a bigger data set, I'll make some assumptions to give you more. So employee, you need to ask yourself, employee, what is the size of employee data set? Employee data, of course, it will be very big. So it will be very big. We need to assume. And location data, which I've just shown you, the US underscore states or CSV, the location data, it will be, when I say very big, it could range up to terabytes. But this location data is nothing but the mapping of the location states to the location name. For example, there are 50 states in US, so 50 rows. That's it, not more than that, right? So location data will be very small, maybe few KBs or few MBs, PMBs. Okay. Now, step one. Of course, we are going to run our map this job on which data set, guys? On employee data. That's a big data set. Okay. Now, employee data has a terabyte of data. So, of course, it will run a lot of map tasks. There will be a lot of map tasks, of course, right? Now, each of this map task, and we know each of the map tasks runs on separate JVM. And what do we mean by separate JVM, guys? Separate JVM means you can consider as a separate process altogether, right? So if there are three map tasks, so they will run on a three different JVMs. And when we say three different JVMs, you can think of a different processes altogether. And when we say that, it means in a very simple term, if M3 dies for some reasons, then it will not kill M1 M2. M1 M2 will still go on functioning. That is known as separate JVMs. That means failure of one task will not affect the execution of the other tasks. Okay, now till now we are good. um, till now you are actually trying to solve the problem, and step one, you have came up to know that I'm going to run my MapReduce job on this, um, what do you say, on the umbrella data. But problem statement clearly states that, okay, but okay, in the map method also. So what you need to do in the map method, okay, in the map method, assumption is you will be having your text input format, blah blah blah, text input format as an input format. So you will get the entire record, you will get the entire one record into your map method, and let's say one record, right? So you get this record into your map method, the first record. So you will split into comma, and you will get 0 1 2 3 4 5 6. Sixth, the sixth position is Alaska, that is, sorry, AK, location ID. In the map method, once you get the location ID from the employee record, how I am gonna get the location name for that? Because location name is in the file location data. The question here is, My question when I'm solving this method, how do I make that location data available to each of the map tasks? How we need to make to each of the map tasks. Why I'm saying each of the map tasks? Because they are not synchronous, right? Each of the map tasks is a different process, so you have to make it available for each of the map tasks. Because just I have told you they run on a separate JVM. So if there are different processes altogether, you need to make sure each of the map tasks is accessible to that location data. How do we make that location data each of the map tasks? Are you guys following me? No, yes, how is it? Okay. So how to make the location data available to each of the map tasks? One possible answer is keep the location data on the HDFS, because HDFS is what kind of file system, guys? It's a virtual file system, right? and and it's a single file system. If you see, HDFS is a one file system. So if you put a data onto the file system, on that file system, will it not be available to all the map tasks? Will it not available to all the machines, right? Because all the machines see only one single file system. So by putting the file onto the HDFS, by putting the file on the HDFS, you can make the file. By putting the file on the HDFS, you can make the file available to all the data nodes, and since it is available to all the data nodes, so it will be available to all your tasks. And since it is available, so it will be for all the tasks. So that's how you're going to solve this problem. That is one way of solving the problem. But yes, this is before I make you understand the concept of a distributed cache. You should understand that if you don't have the distributed cache facility, what how do you solve the problems? Because the distributed cache facility came up after solving the problems like this. The problem will be solved in a very crude manner like this, but then you need to understand what is the performance implications. And once I'll tell you that what is the problem, once I'll try to solve the problem, you will see that the problems can be solved. The problem can be solved in that manner, but there's a problem. But if you solve the problem like the way I'm trying to solve, it will not be acceptable when you have a lot of map tasks. Why? We'll understand it later. But that's where you have a distributed cache facility came into picture, which will solve this performance implication problem. Let us try to solve this problem. So I hope um, this too. How do we do that? Okay. Now the next question which I'm going to ask is, okay, we will keep the file. We'll keep the location on HDFS. By putting the file on the HDFS, you can make the file available to all the data nodes. Now, the next question you to ask, in the map method, where would you like to read this? Where would you like to read this data? That is this location data. In which method? If you have gone through my last class video, then you will not run. You will not. I'm actually saying reading the file, right? Reading the location data. So reading should be done only once, right? It's a static. So the answer is in the setup method. You will read this method. In the setup method, you will read this file and create a map, create a hash map, a lookup table, and you will use this hash map in the map method. Hash map or lookup table, a hash map in the map method for looking up the location name for a given location ID. So now using this, you will be able to read that file. You will be able to solve this problem. Now let us implement this. Okay. Now, the next question which you need to ask yourself: Do we need to do we need a reducer? So if you read this in the map method, once you get the location ID, and also you will be having a setup hash map, right, from which you get the location name. So you don't require reducer. If you see that the problem statement of replacing location ID with the corresponding location name can be very well done in the map method itself. You don't require any reducer method. So we're not going to implement the reducer class. So these kind of jobs, which are where you explicitly set the number of reducer tasks as 0, they are known as map only jobs. Jobs where you can perform everything, where you can solve your business problem in the map method, and you don't require reducer method. You don't require reducer. Those kinds of jobs are known as map only jobs, and you explicitly set the number of reducers to 0. So I'll say what com training em, employ a mapside join dot um, version 1. I will rename this class to employee mapper, refactor rename, employee mapper version 1. I don't require int writable, I'll say text. The reason everybody understands, it's just we have everything as a text, right? Because this is our employee data, and I just need to replace this location ID and then emit it. Okay, as the step 1, so I'm going to override my methods. So select your right click, source, override implement methods. I'm gonna override map and the setup. Okay, I have this map method, so setup method will be called only once. Okay, I can remove this generics, not required. As I've told you that I'll put, okay, so this is our setup method, which will be called only once before starting the map task. Now in this setup method, we will read the file we will read the file on the HDF. We'll read the file, let's say location data, location underscore data from HDFS and form a map, hash map. So for that, we will have a member variable private hash map string comma string location map equal to new hash map. Okay, now what do we need here is the file name. Get the file name. Get the file name. It could be any name, right? You want to put, someone put location data, someone will put US underscore state, whatever name. I just need the name. Get the file name. In fact, I need a path. Let's say get the file path. Get the path of the location data. Okay, where it is placed. Okay, and then what I'm going to do, relative to the, I can give relative to the user's home directory. You can give it so we will, and this will be passed from the, this will be passed as a parameter. The path of the location data will be passed as a parameter. Those who have not attended, those who doesn't know about the pass of the parameter, how to pass the parameter, please see the last class video, that how to pass the parameter to your MapReduce charts. Okay, now what I will say is string path is equal to context dot get configuration dot get and the property name will be location path. That's your property name, location data, or you can say location uh, path on HDFS. That could be a property name, let's say. So that explicitly says that you are actually looking out for the path of your location data on the HDFS. What is that path? Now once you have the path, you need to read the file, and for reading the file you need to first say file, you need to get the file system object. File system org Apache Hadoop, this is your file system. File system fs is equal to file system dot get configuration, context dot get configuration. You need to say to get the get configuration. Now once you have the file system object, you need to open the file. Fs dot open new path of, okay, as I've just told you, you have to give the path related to the home directory of the user. So fs dot get home directory, that will give you the home directory of their user, file dot separator plus path. So what does it means is, the, for example, if it's easy to user, so the home directory path would be hdfs colon slash slash, what are the address of the name node, I'm not sure, slash user slash ec2 user, and if the path name is, let's say the path name, is location underscore location underscore data.txt or data.csv. So this is your path. So this entire path would be user ec2 user slash file.separator means forward slash. Okay, so home directory will just give you till this will give you just this one without forward slash. So you're putting a forward slash and then you're putting this entire path. So this will be the entire path which you are trying to do, fs.open. So this will be the entire path. So and this will give you, if you see data fs data input string, so you get a input stream to read the file, and this is, and now you have got the input stream. You can use several ways of reading the file. Buffered input stream, new buffered input stream, new input stream. Okay, iStream. Okay, so I input stream. I can take a buffered reader, I think. Buffered reader is equal to new buffered reader. One minute, guys. Just 1 minute. Give me a 1 minute. Like, okay, new input stream reader. Input stream reader. I can give an iStream. I can use a reader to read the data from my input stream. So now I'll say line string line is equal to null. Okay, that is the input line, I can say. Now while null not equal to line equal to reader dot read line, what I'm trying to do is I am trying to iterating in a while loop till the entire line, until I have exhausted, till I have read the entire full all the lines from my input data. And how I am doing it, I am initializing to null here, and I am actually saying line is equal to line dot reader dot read line. So it will go ahead and it will iterate till you have you have reached to the end of the file. Now you have got the line. Now you know that's a CSV file. So what you're gonna do here is string array of splits. I can say splits equal to line dot. Okay, for I'll say line dot length. I can put some of the things like if line dot length greater than 1, so that you are not splitting on the spaces. So you are making sure that you are not, if you have any spaces, you ignore them. And then you say string. You are splitting the string. So I'll say splits line dot split. And since it's a CSV file, so I'll put a comma. And I'm actually looking out for two lengths, right? I need, because I know that this will have two, a zero and zero. This is a zero, and this will be the first array. So I will actually make sure so that I'm not reading zero. I don't get into array out of bounds exception. So I will explicitly check if splits dot length. If splits dot length equal to 2, then only bars go inside and process. Wherein you say string location ID. Location ID is your splits of 0, and string location name is your splits of 1. Splits of 1. And you put this in your hash map. This is a hash map, and put this in your hash map, right? Now this dot location dot map dot put. Your location ID is your key, and the location name is your value. And that's it. So what you have done in the setup method, which will be called only once, is you from the parameters, so from the external you will be passing your location path. Then you will read that path from your HDFS. You read that path using this file system object from the. So what you are doing here, you are opening the path. That basically means you are trying to read the path, this particular path. And once you read it, you are reading line by line, and you know that each of the line is a CSV file. So um, that's why you are uh, splitting the data or splitting the record with the comma as a delimiter. So comma as a delimiter. That's why. So I don't like hard code. So what I do generally is to create a strings like this: private final static string comma is equal to, there's nothing. I generally don't hard code anything like this. Just define it as a variable and use it. Okay, line dot split comma. So you're splitting on the comma delimiter, and you're making sure it is equal to 2. Number of lengths is equal to 2, because the first you're looking at location ID and the location name. Once you're done, you're halfway through. Now what you need to do is to this is a value. So you first say string emp data is equal to value dot to string. Correct. Now again you need to check string. You will say if emp data dot length is greater than 1. So you should make sure you are not processing a space. So that's why you are doing this. String splits, you are splitting emp data dot against a CSV record split comma. You are splitting on the comma, and then you have to check what is the location: 0th position, 1st position, 2nd, 3rd, 4th, 5th, 6th. The 6th position is your location ID. Again, you need to check if splits dot length greater than 6, right? So that you are actually accessing the value of the 6th position. So make sure you don't get into a array out of bounds exception. So you're making sure the splits dot length greater than 6. And if it is greater than 6, then you get the string location ID is equal to splits of 6. You get the splits of 6, right? 6, 0, 1, 2, 3, 4, 5, 6. Yes, 6. So you get the location ID, and now you have the corresponding location name. How will you get the corresponding location name? You have the location map, and you say string location name is equal to this dot location map dot get location ID. So for that corresponding location ID, you have to. So if null not equal to location name. So for example, you might not have the location name, right? So you might want to change. You might want to give the actual location name as some unknown or whatever it is. So string location name, you are trying to get the location name, and if the location name is null, then you say location name is equal to, I will again private final static string unknown equal to okay. And what you're gonna do here is context dot write. For the time being, I'm just taking the first split. I'll just take up the first split. That is the first name. I'm not gonna do much of the exercise splits of. I'm just taking the first name, and the value would be new text of location name. So that will be sufficient to solve this problem. So what I'm trying to do here, what I will be outputting is SC Alaska, Cruz Arizona, Billy New York. So I'll take up this name and I'll just replace this, so that my problem statement is actually solved. So I'm able to join these two data sets on the mapper side itself, and hence the name is given as a MapSide join. Also to note that this location map is in memory, because you have created new. So this location map is in memory. Of course, needless to say, location map is in memory. So one important question which you need to answer: if my location data is very big, let's say 1 terabyte or 1 GB, then you will not be able to hold that much of amount of in memory. Then you cannot solve this problem using this particular technique. Okay, the technique which I'm solving is a MapSide join where one of the data sets is smaller. So what we have done, we have actually done a MapSide join, and using this technique, when one of the data set is smaller, we can keep that in memory and use this technique to solve the problem, which is faster because it's a faster technique. But there is again still a problem. I have not introduced that. But using this technique, when I'm on one of, but this technique is basically for those um, when one of the data set is smaller in nature. Smaller, that means it can be hold into the JVM's memory. So you hold that data into memory, smaller data into memory, and you just do a simple lookup because you are doing a simple lookup only. If you see that here, you are just doing a simple lookup, and this is a very fast operation. Simple lookup from the memory, very fast, and you're done. So not we are not doing the lookup here, we are doing a lookup here. Location name dot get. So here we are doing a lookup which is faster. Correct. So now okay, so let us prepare an XML file for this. Okay, queue name. Okay, I don't want to give this property a local because no more we are going to run local, we are going to run on the cluster. So I'm going to remove this property. Job name is MapSide join version 1. The class name, copy qualify name. That's my map class. I don't have a reducer, so I'll remove this reducer. I'm explicit in the, I have a I'm going to explicit set the number of distance as 0 because we don't require anything in the reducer. Output key class is text. Output value class is also text. Map output value class is also text. I don't have reducer, so I can remove this very well. I don't have this. Okay, input format will be Shakespeare. No, this time it will be employee data, right? emp underscore data. I will have to put this data. Output will be, let's say, map output, map join output. But if you see, I'm also passing important. I'm also passing the path of this location path. Okay. The property name is location path on HDFS. I'm very sorry. And the location path would be under EC2 user. So we are going to put the data under username, under the user's home folder. Keep this data under users, under location folder, let's say, under location folder. So my data would be location slash location data dot csv. So actually, if it is our EC2 user, then the data set will be something like this: slash f okay hdfs colon slash slash the address of the name node slash user slash ec2 hyphen user slash location slash location underscore data dot csv. Okay, and the I'll say employed. Okay, let it be employed data set. That's okay. Or I can put into one folder, employee slash emp underscore data and location slash location data.csv. I can always give employee only, right? Employee underscore directory, so that it is known. It's a directory under which we are going to put one data set, which is employee data. Location underscore location slash location data. Okay, that's it. We have to do this, and let us now start our cluster. Let us now build the code first. Let me also download this dataset on my local box and send it to my cluster. Okay, scp-i Hadoop Training.pem and downloads employee table.csv. Um, ec2-user at no okay user at hostname colon home ec2-user. Okay, similarly I have to pass this location table us underscore states dot okay, I have passed that folder. Now we need to pass our jar also, target. Okay, we need to pass our jar target what count snapshot hyphen shaded dot jar, and also if you remember we need to pass our XML file to a cluster so that we can pass our XML file, right? The name of the XML file is MapSide join version 1. Now let us start our cluster Ambari. Okay. This is our jar. This is our table ex employee table. And where is our data? Yes, this is our data, location data, and this is our XML file. Once it gets started, we are gonna do that activity of MapSide join. Okay, so but that is a traditional way. Okay, I have not yet introduced the concept of a distributed cache. The correct way of solving this problem is using the distributed cache. But if someone asks you that if you don't have the distributed cache problem, then this is a workaround. That this is a workaround of solving the same problem. But this has a problem which I'm going to explain later. What is that problem? Let's one more time check whether we have done everything correct or not. Whether the queue name, the job name, the class, the number of decent tasks, text. We don't require this, right? Anyways, that's fine if we don't require this. Location path. This is a property name. In fact, the property name should never be given like this, but we have given it should be like dot 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 and all. That's not the way. That's not a standard way of giving the property names. Okay, it's still 87%. Okay, anyways, HDFS has started, so my job is I have to just first and foremost I need to say k list. There is no ticket. Okay, there's a ticket which was on the June 1st and all. So k in it. The password is training. K list. It is 2070. Okay, and what I'm gonna do here is HDFS DFS minus ls. HDFS DFS minus mkdir. And what was the input directory which we have given is employee directory, right? HDFS empl employee underscore dir. Okay, that's the directory. And the other one which we have in location, HDFS DFS minus mkdir. I have given the location. Now this US underscore states or CSV, I have given the location data underscore CSV. So let us put as location data underscore CSV as DFS minus put US underscore states or CSV under the location by the name location data.csv. Okay, and let us put our employee data employee table.csv in our employee directory with any name, because I am going to give the entire directory name, right? So employee underscore directory, excuse me, done. Let us verify at dfs minus look ls location. I should see a data by name loc underscore data.csv. Also, let us check whether data is present in our employee directory or not. Okay, we have the data set employee table underscore csv. That's the time to now a job Hadoop jar name. What count? So, but yeah, we have given the name as a what count. Hadoop jar name fully qualified to our class name. That would be then minus conf. You have what is that MapSide version 1.xml. This is MapSide version 2 version 2 I have given. Okay, I'm sorry. Some problem came up here. It says that inside the map method, null pointer exception text.set Java 71. Okay, so the problem here is null pointer exception text.encode init set splits of 0. Okay, splits of 0 splits. This is gonna be splits comma. Shouldn't be any problem here. Even if it is, this cannot be null, because if it is null, then it is renamed to unknown, so it will be unknown. So there is no problem having a null, and this guy can be null or what? No, this guy is not null. If it is a null, then it have to throw the null pointer exception at this point. So this guy will never be a null, because anyways we have initialized this guy here. So that is fine. Location name. If it is null, if null is not okay. If it is null, okay, this condition is wrong here. If location name is null, if then only we are going to change to unknown. If it is not null, then we'll take as is. And are we reading this file or not? That's my concern. So how do we now actually logger will print it. Okay, logger.info. Let me put a logger here. I think the name could be so I can put logger.info here. Logger.info, reading the file. Path. And what I'm trying to do here is I'm actually trying to read this file. Let me see whether we are able to read this file or not. But it would have thrown me an exception right away. It has not thrown an exception, so which means that it has successfully read the file. But still, I would like to logger dot. I would like to print it. Location path. Logger.info. Fully qualified location path. And I would like to size. Okay, and also I would like to put it here. What is my location name? Name, that's a employee name, let's say. splits of 0 comma location. Okay, build that maven clean install. Let me delete the jar from here. rm-f word count snapshot jar. So I need to say fcp -i aws pim hadoop training.pim, and I would like to pass my target word count shaded.jar to ec2-user at the host name. Host name is this. Host name is this colon home ec2-user. Output directory needs to be changed. Vi MapReduce MapSide join version 1.xml shift G, and I will change the output directory name to something different. Okay, now let us run it. Now this time if it throws an exception, then we'll go to the logs and figure it out what is going wrong. Okay, it has successfully done everything, but okay, let us see what is the output. So at dfs -ls, what we have given the output name, someone we have changed, right? Okay, at dfs, so dfs -cat head -50, first 50, top 50 lines. And I hope if you see here, we were successfully able to SE Alaska. Okay, let us go to our dataset. Employee SE AK was Alaska, Cruz Arizona, Billy New York. You can see that Jackery New Jersey, Rosemary HI Hawaii, Bernard IL Illinois. The one which has not been done, Justina, this lady Justina, there was no mapping of this TN on my in my employee dataset, location dataset. Let me search for TN. There is no TN here. Oh, TN Tennessee. Yes, then why it has not been able to just TN, right? Then it is not doing it. I don't know why. So this like Justina unknown. Okay, so we need to figure it out then why it has not been. TN is here. Maybe some space problem or whatever it is. I don't know. Some could be some problem, space problem. There are 50 states in United States, so there are 50 is there, but not sure. But you can figure it out why it is not coming up, and then you can let me know. Okay, but if you see that we have done this guy Colin is unknown. Colin. This is also unknown. After no Colin, yeah, Rubin also. It's a CA, California. It should be there, no? 0, 1, 2, 3, 4, 5. So it could happen that, see, there are a couple of commas here. I think because of that, when we are splitting onto the comma as a delimiter, then it might have happened that this is taken as a location ID and something has gone wrong. You got my point, guys? Because this section where the address is there, in between it could be a comma as a delimiter. We are dividing, and that could have happened perfectly. So we need to figure it out when we are processing this data set. We are actually when it is a comma separated, we cannot rely on the comma anymore. What we need to do, we have to ignore somehow the commas and everything, and then we have to work. That's why any of those which has a comma here in between in this C column, for example, Colin, if you see that, that also is unknown, right? I can see here this could be wrong. Shelly could also be unknown. If you see the output, Shelly, see this Shelly, this is also unknown because what I'm finding here is comma here after Norton. So the sixth position will be something different. So that's why it is not able to do that. So we need to, either the data set has to be, we have to do something, or we have to modify this data set so that there are unique number of commas. That means which separates these fields, or the delimiter could be a something else, which could be a pipe or which could be anything else. But nevertheless, we have proved what we wanted to do. We have done. This is a map site, John, right? But this has a problem. The problem is the way you have solved this problem is the performance. What you have done is the location data is on HDFS. Correct. Yes. And each of the map tasks in their setup method, is reading this data and creating a hash map. Right? You have seen that. And that is the problem. So how do you read the data from HDFS? How does the reading happens in HDFS? If you have seen the HDFS architecture, first the client will contact the name node. Correct. Client will contact the name node. Name node will give the list of the data nodes, which are hosting those blocks. Then the client will read the data from the data nodes and form a file, and then you start reading. Right, actually reading of the data and forming the hash map and all, it will happen after these three steps, and this is going to be, then this is a very slow process because you have done 3 times. So this is a slow process, and if a lot of map tasks are running, then reading the data from the HDFS could be very slow, and this is where this approach is not suitable. It's not suitable. I'm not saying it's not valid. It gives you the output, but it's not suitable. Okay, so how to solve this problem? how to solve this performance problem. So if you see that reading the file from the HDF is a problematic, because reading the file from the HDFS is a slow process. From the HDFS is a slow process. So what if, so if each of the map tasks reads this extra data, that is location data in our case, reads this extra data from its local file system, then it would be very much faster, right? Instead of reading from the HDFS, they read it from their respective local file system. Then it would be a very faster. It would be very fast operation. That's why you have a next question, that how to place this extra data, that is location data in our case, onto the local file system of not all the machine. It has to be placed on the local file system of only those machines where the task is running. And that's where if you have this situation wherein you are running a MapReduce job and you think that it could be a map side join, right? Like we are doing this one employee data, another location data. Employee data is a very big, location data is small. You need some information of the location data and you wanted to have this situation, like you will read this location data in and you will create a hash map. After getting the hash map, you will use that hash map inside your map method. If you have this some kind of a situation like this, then you should not go the way, you should not follow this way, the way I have just demonstrated. But what you should do, you should be using the distributed cache facility to place the file onto the local file system of all those machines. So answer is, for that above question, is you will be using distributed cache facility, using which the file, and I would say the smaller file, you will not distribute it cache. So you will not distribute the larger files, but what you will do, you will use the smaller files, smaller in size. So using which the file smaller in size will be placed onto the local file system of all those machines where the task is running. That's it. So you'll be using distributed cache facility, which I'm going to explain in the next class, that how to use the distributed cache facility. It's just a 2 lines of a code, but then you have understood what is the motivation of the distributed cache. Distributed cache, wherein you have a scenario where you wanted to pass some extra data smaller in size to your MapReduce job, then you will use the distributed cache facility to place the file onto local file system of all those machines. And in the mapper or reducer, wherever you wanted this data to be read, you will use in the setup method, not in the map or reduce method. You will use in the setup method, because reading the file, you will not do it for every record, right? You wanted for every block of data you wanted to populate once, so you will use the setup method, and then you will create whatever data structures you are interested in, and you will use the data set, right? So we'll see that in the next class, how to use the display cache facility, just a few lines of code. Okay, thank you guys. Let's meet in the next class. Bye.